Alright, in this video, we're going to put together our waypoints. So all we're going to do here is we're going to create our individual waypoint mono behaviors, and we're going to create a waypoint manager that's responsible for managing the waypoints, in that they will disable the waypoints that aren't currently active and enable only the one that is. The way that the system will know what waypoint is going to be the next waypoint is through a special property on our waypoint script. So I'm going to go ahead and delete our companion cube. And well, I'm sure we'll end up needing another cube of some sort by the end of this series, but whatever. I'm going to jump into Visual Studio, and I'm going to put together the skeleton for the waypoint in the waypoint manager. So in code, I'm going to create a waypoint. The waypoint is going to be a mono behavior, which of course brings in the using Unity engine at top. Then I'm going to give it a couple parameters. I'm going to say public waypoint next, and then public float time modifier, followed by minimum velocity. So what happens is every time you hit a waypoint, you get X amount of time added to the amount of time you have left, and your player also gets set to have a new minimum velocity, meaning you can slowly make the game more and more difficult by forcing the player to go faster and faster. He is going to have two methods that I'm not going to flesh out just yet. He's going to have a public void start and a public void on trigger enter collider collision. So that's our waypoint stub, I guess you could say. The next guy we have to write is our waypoint manager. Our waypoint manager is going to be a mono behavior, which of course we'll bring in using Unity engine up top. As far as the stub for this, the only public members that we're going to have is a public waypoint first waypoint. Now the last waypoint is going to be detected when the waypoint next is null. Then he's going to have a public void start method, and then he's going to have a public void player hit waypoint method. So those are the stubs for these two mono behaviors. Let's jump into Unity, configurize them, and then come back here and flesh out the code. So coming back into Unity, what we need to do first is to create a waypoint prefab. Now there's an interesting little, I have a cool little guy here that we can play with. Our nice little portal dude. So what we're going to do is we're going to import that, create a prefab out of it, and make it rotate, because that sounds like fun. And
that does sound like fun.
To be fair, that was Steve's idea.
That's why it sounds like fun.
Okay. Well, yes. Well, no. I don't know.
And then why it won't be as fun as it sounded.
Okay, so I'm going to jump into the Scratch scene. I'm going to delete out our asteroid prefab, and let's go ahead and start constructing our waypoint. So I'm going to go ahead into game object create empty, and I'm going to call this waypoint. And then I am going to create an empty object underneath that, and let's call this ring 1. And let's create, actually let's wait until we finish ring 1, and then we'll duplicate it to create ring 2. Make sure that they're both zeroed out in X, Y, and Z, and they're all rotated to 0. Now I'm going to import Portal, FBX, and Portal TGA, and let's go ahead and fix that extension because I really don't like capitalized extensions. I'm going to go into Models, and I'm going to click and drag Portal 1 FBX into Models. Then, just to keep things organized in the way that I've established, I'm going to delete the automatically generated materials folder, go back into Models, create a new folder called Portal_01. Under that, I'm going to bring in the diff and the norm for the diffuse and the normals. Click and drag on there. Wait a second. And I'm going to jump into normal real fast and set it as a normal map and hit apply. Next up, I'm going to go back into my Portal 01 folder and create a material. And the material is going to, let's just call it Portal 01. It's a very uninspired name, but it should work for our purposes as far as the material goes.
It's conversely organized as it is uninspiring.
Yes, that's fairly true. Um, as far as a shader, like usual, we're going to, because we have a diffuse, this one has a specular map on it, right?
In the diffuse, no, this one doesn't.
Okay, so in that case, we're going to hit a bumped diffuse because we don't have a specularity map in the alpha channel. And then I'm going to click and drag diffuse onto our base, and I'm going to click and drag normal onto our normal map. So now that I've done that, I now have my Portal 01 material created. I'm going to go back to my Ring 1 game object, and I'm going to add a mesh filter. I'm going to select our tube 001 as our mesh. And then I'm going to add another component for mesh renderer. And whoa, it's really purple. To fix that, I just got to click and drag my Portal 01 material right onto my mesh. And hey, look, a ring appeared.
Awesome.
Sweet. So let's go ahead and duplicate our ring and size it a little differently. So I'm going to click on ring 1, hit Control D. Then I'm going to rename it to ring 2. I'm going to open up my sizing tool. And do you think that's good? Or should I go smaller? I guess the artist has no input. Okay.
Oh, I was very muted. I was going to say make it smaller because apparently I made that much huger than I did the ship meshes. I thought I was fairly on the mark, but
Oh, that's all right.
I was hurried.
Okay, so now we have this. Let's go ahead and make them rotate in opposite directions. So how do we do that? Well, because of the modular nature of Unity, I can just go ahead and write a mono behavior that just rotates whatever game object it's attached to, and then I can apply that one mono behavior to ring 1 and one to ring 2 and invert their directions. And that should look really cool. And
That's exciting. It
yeah.
sounds pretty easy compared to a lot of ways of doing it.
Oh yeah, it's incredibly straightforward, and that won't in any way impact the logic I'm going to be placing on the waypoint game object itself.
Cool.
So what I'm going to do is I'm going to go back into Visual Studio, and I'm going to go into code, and I'm going to create a new class, and let's just call it Rotator. Or Spinner. What's Spinner? And let's go ahead and make it a mono behavior. Then I'm going to say public bool direction. So one direction will go one way, and the other direction will go the other way. Now to figure out what axis I'm going to be rotating on, that's actually very simple to do. I just go back to Unity, look at my rotate tool, and I need to rotate on the z-axis because that'll give us that effect. So to do that, let's go ahead and have direction, and then let's just, well, rotate by time delta time every frame. So I'm going to say public void update, transform, rotate, and I'm going to rotate on the x of 0, y of 0, z of time, delta time. Let's do times 20, so 20 degrees per second, and space relative to our self. However, I need to invert this if the direction is false. So I can simply say multiplied by direction question mark -1:1, and then wrap these in parentheses. And then that way, if direction is true, it'll go negative, and if it's positive, or if it's false, it'll go positive. Let's invert that. Like it makes a difference, but still, I like to think of true being positive and false being negative, but that's just me.
No, that makes sense, and I would think everyone's head.
All right. So now that we've done that, that is our awesome spinner script. We might have to adjust that coefficient, but I don't think we should. Well, maybe. Let's just see what happens. I'm going to go into open my code folder, and I'm going to click and drag spinner onto ring 1. I'm going to keep its direction unchecked. On ring 2, I'm going to click and drag spinner onto it, and I'm going to check this one. Now I'm going to bring my camera out so I can see it from an angle here and see how it looks. By hitting play.
That's pretty cool. I'd
Yeah,
even say you nailed the speed. Nice job.
yeah, looks good. I like it. Okay, so that is our actual representation of our waypoints, but we still need to put the logic in it. So what I'm going to do is I'm going to attach the waypoint script to our waypoint. I'm going to keep next, time modifier, and minimum velocity to 0 because all of those things are things that we will change on a per waypoint basis. But what I will have to do is I will have to add in a collider. I'll need to know when the player actually enters the waypoint. So to do that, I'm going to add a collider directly to this, and I'm going to make it a, I don't know, I could make it a,
What are our options?
we have a box, capsule, sphere, wheel, I think
I think wheel.
well, a wheel, that does weird things. The wheel's for simulating physics for cars, which isn't a car.
Mm.
I think a capsule collider should work. Up its radius a little bit. And then set it along the z-axis. Yeah, actually that looks pretty good. That's looking pretty good. And then let's offset the z inside of it a little bit, so they have to actually get inside of it first.
There you go.
All right, so that's our collider. So when the player hits that area, they will be considered to be going on to the next waypoint. So let's go ahead and make sure that we hit is trigger on that, because it's not actually going to be computing any collisions. It's just going to be a trigger volume. So now that we have our waypoint created, we can go back into our scene by going into Scenes, Game Test, setting up a few waypoints, and setting up our waypoint manager. Let's start with creating our waypoints. I'm going to go into Oops, I never prefabified it.
Oh, you didn't prefabify?
No, I didn't.
No.
So let's go ahead and click and drag waypoint onto our prefabs folder, and then jump back into Game Test, save that out, and whoa, that's big. I'm going to scale you down a little bit. Okay, so let's have a waypoint there. There is one thing we're missing. We're also missing our targetable script. To do that after the fact, after I brought in a prefab, and then to apply it to all the future prefabs, we just go into Code, click and drag targetable onto it, and then hit Apply. And that will apply the addition of the targetable script to everyone.
Nice.
Yep. So let's set up...
And good to know.
Yeah, it is actually. It's very useful. So now I'm going to set a waypoint there, and a waypoint there. So I just have 3 waypoints. Now if I hit play, we have... Whoa! Those are really tiny. That's kind of funny. Let's make them a little bigger. Maybe I should have just left the size as they were. See, here goes me trying to... Actually, no, I think that's good.
That's pretty good right there.
Yep. So now we have our waypoints, and that's super awesome. So now, before we get to writing our code, let's go ahead and hook these waypoints up to each other, and then create our waypoint manager. So I'm going to name these waypoints so they're easy to find inside of my hierarchy. I'm going to name the first one waypoint 1, the second one waypoint 2, and the third one waypoint 3. Now to hook them up to each other, all I got to do is open up my waypoint script and drag waypoint 2 onto the next of waypoint 1, and then waypoint 3 onto the next of waypoint 2. Next up, let's go ahead and set up some modifiers. They won't do anything yet because we haven't written any code yet, but let's go ahead and do that anyway. I'm going to say you have 10 seconds to get from waypoint 1 to waypoint 2, and your minimum velocity increases to 30. And then you have 5 seconds to get from waypoint 2 to 3, and your minimum velocity becomes 100. So you're going to go super fast, but It should make
and crash and die.
Yeah, but still. Next up, let's go ahead and create the waypoint manager, because the waypoint manager game object needs to know what the first waypoint is so that I can enable and disable them as the player moves through them. So under my manager's game object, I'm going to create another empty one, and I'm going to call it waypoint manager. And then I'm going to go into code. I'm going to find waypoint manager script, the waypoint manager script, click and drag it up here. And then I'm going to set the first waypoint to waypoint 1 by clicking and dragging from my hierarchy into my first waypoint property. Okay, so all of that work actually did, well, nothing as far as the code's concerned. So let's go ahead and jump into it and see what we can do. Close out our spinner, because I think our spinner is fine. Let's do our waypoint manager first. Now our waypoint manager is going to need a reference to a couple of different things. We're going to need a reference to the current waypoint, which is simply going to be waypoint current waypoint. And when I said it needs a reference to a couple of different things, I was actually getting a little ahead of myself. We'll see what I mean by that in the next video. So the current waypoint is always going to be the first waypoint, so I'm going to do that. Then what I need to do is I need to disable every single waypoint in the chain of waypoints, which is except for the current waypoint. That's very easy to do with a simple while loop. If you're familiar with the linked list, this is very similar as far as implementation goes. I'm simply going to do var waypoint equals current waypoint dot next. Then I'm going to say while waypoint does not equal null, waypoint game object set active false waypoint equals waypoint. Yeah. Oh, really? Waypoint equals waypoint dot next. Yeah, I'm not even typing right now, and you saw how slow that was coming in. I don't know. Visual Studio sometimes has emotional issues. Okay, so what I want.
It kind of seems like Google's trying to take over Visual Studio. I've never seen it type in wrong words for you so much as it has this series.
Yeah. No, that's a new version of ReSharper I'm using with the new version of Visual Studio, which I'm still evaluating. I'm not sure if I'm going to buy Visual Studio 2013 or ReSharper 8. I'm happy with 2012 and ReSharper 7. But anyway, when the player hits a waypoint, what we need to do is we need to deactivate the current waypoint that was hit. So I'm going to say waypoint deactivate. The reason I'm saying waypoint.deactivate instead of just directly deactivating it is because I want it to fade away. Next, I have to say current waypoint equals waypoint.next. Not network view, next. Then I'm going to say if current waypoint equals null, return. Otherwise, current waypoint game object set active true. Okay, so that's our waypoint manager, but we're still missing the second piece to that, which is our waypoint class itself. Jumping into our waypoint class, let's go ahead and throw in a private member, which is going to be a reference to our waypoint manager. That's because our waypoints themselves need to inform the manager when the players hit them. On the start, I'm simply going to say manager equals waypoint manager, and you guessed it, find object of, come on, there you go, of type. There you go. Manager equals cast to waypoint manager, find object of type of waypoint manager. Now, on trigger enter, what I'm going to do is I'm going to say if collision.gameObject find component, so I'm using my find component method, not the get component method, of player equals null, that means that something that wasn't a player collided with our waypoint, then simply return. Otherwise say manager player hit waypoint this to inform the manager that the player hit the waypoint. Now we have to implement our deactivate. Our deactivate is going to be implemented with a basic interpolation of an alpha channel. So I'm going to say private float alpha, which in start I'm going to set to 1. Then I'm going to say public void deactivate, which is going to set, or sorry, private void alpha, and I need a private boolean deactivating. On deactivate, deactivating is set to true, and alpha is set to, well, alpha is not set to anything. So now that when we know when we're deactivating, we have to write an update method that'll change the alpha channel of our material through the use of an interpolation method. So I'm going to say public void update. I'm going to say if not is deactivating, return. Otherwise, let me full screen Visual Studio so you guys can see more. Otherwise, alpha equals mathf lerp between our render material color A to 0. Time is time delta time times 5. Then I'm simply going to say render material color equals new color 111 alpha. And then I'm going to say if alpha is smaller than 0.01f, then we're simply going to say game object set active false. So it deactivates itself automatically.
Alrighty.
Okay, we're missing one more thing with the alpha effect. And that is, remember, in order for the alpha channel to have any effect on our material, we have to go back and make sure... No, I used bump diffuse. Whoops. We have to make sure that we're using a transparent shader, which are slightly more expensive, but we're not going to have a whole lot of alpha or a whole lot of waypoints in the scene anyway, so it's not really a big deal. So the shader I'm going to set to transparent bumped diffuse. So now it supports an alpha channel. So if I play and I run through this portal, we get a null reference exception. That's because there is no renderer actually directly attached to the waypoint.
Okay.
So this is what happens when you try to code in FX. Yeah. Okay. It's actually very easy to fix. What I'm going to do is I'm going to create an IEnumerable of renders called renderers. So that brought in using system collections generic. And then on start, I'm going to say renderers equals get components in children. Come on. Of type renderer. So now I have a list of all the renderers that are attached to any of the children of my waypoint, which is cool. Then what I'm going to do is instead of saying render material color equals alpha, I'm simply going to say for each var render in, I'm saying render instead of renderer because render is a existing thing. I say render material color equals new 111 alpha. Finally, the current alpha color is not render material color A. That would work if there was a single renderer attached to our script. But in the case that we don't have that, which we don't, we have to supply our alpha as the current value. And our target value is, of course, still 0. Phew. So now if we run into this guy, he should slowly fade away. And that was I really like that, actually. It's cool. I think that was worth the slight embarrassment of completely messing up in front of everybody. Thousands of judging people.
You are being judged.
I am being judged. But you know what? That's worth it because every time I want to do this again, actually. This is fun. This is pretty cool, isn't it? Anyway, so that's our awesome little waypoint system. But we have one more issue with our alpha implementation. And I decided to not bring this up until we could see exactly what's going to happen when we apply that transparent shader to our mesh. Jumping back into Unity and zooming in on one of our waypoints, we can see the problem almost immediately. We see that there is a visual artifact that's caused by two of these objects being transparent and overlapping each other. Now, transparent shaders follow different rules for calculating the depth of a particular pixel, so Unity doesn't know how to render this properly. Now, instead of going, really crazy advanced and getting into writing our own custom shaders, we can actually use a very cheap and very efficient and very quick hack to fix this problem. Effectively, what we're going to do is we're going to reset our shaders back to using the old shader, just the normal bumped diffuse shader. Then we're going to actually switch the shader once it starts to fade to take advantage of the alpha channel. This is also an optimization technique, as the transparent shaders will imply different performance characteristics on our rendering path. So let's go ahead and do that. Like I said, the first step is going to be to go to Portal 01 and to change its shader back to bump diffuse, which you see now the artifacts go away. However, now none of our alpha channel information is going to be used, so we have to figure out a way to make it so that when we do move through the ring, the shader is switched to a shader that supports transparency. And because the effect is so quick, I highly doubt any player is going to notice the small visual discrepancy. And again, like Steve says, CG is pretty much all cheating anyway.
Yeah, it's all sleight of hand.
It's all sleight of hand, exactly. So I'm going to jump back into Visual Studio. I'm going to scroll all the way to the top to waypoint, and I'm going to add another field to it. Now the other field I'm going to add to is public shader alpha shader. And the reason I'm doing this is so that we can apply the shader from the inspector and we don't have to try to locate it manually through code. Now what I'm going to do is when we start deactivating our gates, I'm going to loop through all of our renderers and swap out their material shader. So I'm going to say for each var render and renderers, render dot material dot shader equals alpha shader. And that's it. All that's left is actually telling the gates what I want the alpha shader to be. So jumping back into Unity and clicking on one of our waypoints, we'll see that a new property has opened up right here, our alpha shader. So I'm going to click this little target button so I can locate one of the built-in shaders in Unity, and I'm going to select transparent bumped diffuse, double click it. Now we've set this on this one instantiated prefab, so I'm going to go and hit apply to make sure that that gets applied to all of the rest of our prefabs. Now hitting play again, we'll see that there is no more visual artifact while it's normal, but it does still fade. And the effect again is so quick that we don't actually notice the fact that there is a small visual artifact during the fading process.
Very sweet.
All right, so jumping back into Visual Studio, we have a couple more, one more thing to do. We have some more stuff to do with our waypoints themselves, such as actually modifying the time that's left. However, that's not going to matter right now because we don't actually have our level manager built. But what I do want to do is I do want to edit the minimum velocity of my player whenever he hits a waypoint. To do that, I simply have to add pretty much a couple lines of code to my waypoint manager. First of all, I need to retrieve a reference to my player so that I can modify his minimum velocity. So I'm going to say private player, and then I bet you guys can't see what's coming. Player equals player find object. Oh, come on. There. See, I'm just.
Damn, it's really lagging.
Yeah, I'm just typing blind. Like, very frustrating. Anyway, so we'll grab a reference to our player, and then when the player hit a waypoint, I'll say player.minimum velocity equals waypoint.minimum velocity. Now you'll see an interesting problem. The way that I have organized my player is to effectively hide as much of his implementation as I can from everyone else, and have it so you access that implementation through the player script. thus making the player kind of the owner, or you could even say aggregate root if you're into that sort of thing, of this particular system, which means that to access any of these subcomponents, you must go through this interface of the player class. Now, that does lead a lot of confusion to people. People commonly think, well, why can't every bit of data that I have be public and made available to every single class? Well, then things get confusing. And for example, if the way in which you change data is different than changing that data directly, you have no way to add additional functionality into that modification. That was a really roundabout way of saying what I was trying to say. But my point is that this class is the mediator of the player as an entire unit to the rest of the game. There's no way for us to directly modify the minimum velocity because the minimum velocity is something that is owned by our player controller. So how do we do that? Well, it's very easy. We create a property on the player called minimum velocity. Minimum velocity. That simply is a proxy for controller.minimumVelocity. So its getter will simply return controller minimum velocity, and its setter will simply set minimum velocity to value. So that's how our player class becomes an interface into this entire subsystem that we've built. And we can retain our encapsulation and cleanliness of our code. So now that we've done that, I'm going to jump back into Unity and hit play and see if our minimum velocity is indeed modified by running through these awesome disappearing waypoints. And in fact, it is.
Very nice.
That's fine. I want to do it again. Awesome. So I think that pretty much wraps up our waypoints. We'll see you guys in the next video.
All right.